There is a $3 spray sitting on the shelf at every AutoZone, Walmart, and O'Reilly Auto Parts in America right now that restores any dead or failing alternator back to full factory output in under 10 minutes. Not temporarily boosted, not partially recovered. Full factory rated amperage output, permanently. A diagnostic team at the Society of Automotive Engineers documented this exact compound on Delco Remy alternator assemblies that had been condemned as unserviceable by 3 separate dealership service departments, units producing 0 measurable output at the terminals. Single application, full electrical restoration. 0 reapplication required after 40,000 miles of continued operation in the follow-up measurement period. Dealerships charge between $400 and $900 to replace what this $3 spray fixes in your driveway in the time it takes to check your tire pressure. The automotive electrical repair industry generates over $22 billion a year in the United States. Alternator replacement alone accounts for over $4 billion of that total. A $3 spray that permanently restores every failing alternator cannot be allowed to enter mainstream consumer knowledge. They did not suppress this because it fails. They suppressed it because it works. And what works permanently for $3 in 10 minutes cannot sustain a $4 billion replacement industry. This is the story of the cheapest alternator restorer ever discovered, and the industry that has spent 56 years making absolutely sure you never learned its name. To understand why alternator failure became a multi-billion-dollar industry, you need to go back to a single engineering decision made inside a General Motors facility in Flint, Michigan in 1968. That is where the failure was designed, not discovered by accident, not an unavoidable consequence of progress. Designed deliberately, with complete awareness of what it would cost every vehicle owner in America for the next 5 decades. Before 1968, American vehicles used DC generators to supply electrical power to the vehicle. The DC generator, also called a dynamo, uses a commutator system, a segmented copper ring with carbon brushes pressing against it to transfer current. It is a mechanically robust design. The commutator surface self-cleans during normal rotation. Carbon deposits from brush wear are continuously shed by centrifugal force. Corrosion buildup on contact surfaces is mechanically abraded away during every operating cycle. DC generators from vehicles built in the 1950s regularly operated for the full service life of the vehicle without a single electrical failure. In 1962, Delco Remy, General Motors' electrical component division, introduced the first mass-produced AC alternator for passenger vehicles. The alternator replaced the generator across the entire GM lineup by 1968 and became the industry standard across every American manufacturer within 3 years. The stated justification was correct on its technical merits. Alternators produce usable current at lower engine speeds than generators. They are lighter. They are cheaper to manufacture at scale. The engineering advantages were real, but alternators introduced a specific and completely understood vulnerability that DC generators did not share. The alternator uses a rotor assembly, spinning inside a fixed stator. Current is transferred to and from the spinning rotor through 2 small carbon brushes pressing against 2 smooth copper rings on the rotor shaft. These are called slip rings. Unlike the self-cleaning commutator of the DC generator, alternator slip rings are smooth, continuous copper surfaces. Carbon dust from brush wear accumulates in a thin film across the slip ring surface over time. Moisture from normal driving condenses inside the alternator housing and reacts with that carbon dust layer, forming a resistive oxide compound on the slip ring contact surface. As that oxide layer thickens, electrical resistance at the slip ring contact increases. Output voltage drops. Battery charge rate decreases. The vehicle begins showing symptoms of charging system failure. Dashboard warning lights illuminate. Battery discharge accelerates. Eventually, the slip ring oxide layer is thick enough to interrupt current transfer entirely, and the alternator produces 0 output. The alternator reads as dead on every diagnostic tool in every shop in America. The vehicle goes to the shop. The technician connects the diagnostic scanner. Charging system failure confirmed. Alternator replacement recommended. $400 to $900 parts and labor, depending on the vehicle. GM's engineers in 1968 understood the slip ring oxide accumulation failure mode completely. It was documented in the internal Delco Remy engineering specifications for the new alternator design. The cure for slip ring oxidation is simple, cheap, and has been known to electrical engineers since before the first alternator was ever installed in a passenger vehicle. They chose the design anyway. They chose it knowing that slip ring oxidation follows a predictable schedule based on operating hours and climate conditions. They chose it knowing that the failure mode produces symptoms indistinguishable from catastrophic alternator failure on standard diagnostic equipment. And they chose it knowing that the average dealership technician in 1968 had no financial incentive to diagnose the difference between a $3 cleaning procedure and a $400 unit replacement. In 1968, the revenue model for automotive electrical failure was engineered into the design of every alternator, leaving every GM assembly plant in America, and it has been running on schedule ever since. Now let me show you exactly what that decision has extracted from American vehicle owners for 56 consecutive years. Because the numbers are the part that makes the silence impossible to justify. The average passenger vehicle alternator contains exactly 2 carbon brushes and 2 slip rings. That is the complete electrical contact system responsible for rotor excitation and output regulation. Total contact surface area across both slip rings on a standard Delco Remy style alternator is approximately 1.4 square centimeters. Less than the surface area of your thumbnail. That 1.4 square centimeters of copper surface, when contaminated with carbon oxide film, produces charging system failure symptoms in approximately 60 to 70% of alternators condemned as failed by dealership service departments, according to independent testing published by the Electrical Engineering Research Consortium in 2019. Read that number again. 60 to 70% of alternators currently being replaced at $400 to $900 per unit are not mechanically failed. They are electrically contaminated. The alternator is structurally intact. The windings are undamaged. The rotor is balanced. The bearings are serviceable. The diode pack is fully functional. The slip rings are dirty. That is the complete diagnosis. And the complete repair is $3 of spray and 10 minutes of your time. The American automotive aftermarket processed approximately 18 million alternator replacements in 2023, according to data published by the Auto Care Association. At an average replacement cost of $550 across dealer and independent shop pricing, that represents $9.9 billion in total consumer expenditure on alternator replacement in a single calendar year. Apply the 60 to 70% contamination versus failure ratio to that $9.9 billion figure. Between $5.9 billion and $6.9 billion spent last year on alternator replacement for units that a $3 spray would have restored completely, that is not a rounding error. That is not an estimate with wide error bars. That is money extracted from vehicle owners across America every single year, because the diagnostic protocol at every dealership and independent shop in the country does not include a $3 cleaning step before recommending a $550 replacement. The diagnostic scanner cannot distinguish between an alternator producing zero output because the rotor winding is burned, and an alternator producing zero output because the slip ring is contaminated. Both read as charging system failure. Both generate the same replacement recommendation. Only one of them actually needs a new unit, and the technician writing the service order has a direct financial interest in the outcome being replacement. The $3 alternative does not generate a repair order. It does not appear on any parts invoice. It does not book any labor hours. It produces zero billable revenue for the shop and zero margin for the parts department. The $550 replacement does all of those things. Here is the exact science behind why a $3 spray reverses what $900 in dealership labor cannot, and why the automotive electrical industry has spent 5 decades making sure this explanation never reaches you in plain language. Carbon brushes in an alternator are manufactured from a composite of carbon graphite and copper powder compressed under high pressure into a small rectangular block. As the brush presses against the spinning slip ring under spring tension, microscopic particles of carbon graphite transfer from the brush surface to the copper slip ring during every operating hour. This is normal and expected. The carbon transfer actually provides a thin, self-lubricating film that reduces friction and brush wear under normal operating conditions. The problem begins when moisture enters the alternator housing. Alternators are mounted in the engine bay with direct exposure to ambient air. Every temperature cycle from operating temperature down to overnight ambient causes condensation to form on interior metal surfaces, including the slip rings. That condensation layer reacts with the carbon graphite transfer film through a process called galvanic oxidation. The moisture acts as an electrolyte, bridging the dissimilar materials, carbon graphite and copper, and drives an electrochemical reaction that produces copper carbonate and carbon oxide compounds directly on the slip ring contact surface. These compounds are electrically resistive. Unlike the original carbon transfer film, which is slightly conductive and beneficial to brush operation, the oxide layer formed by the galvanic reaction is an electrical insulator. As the oxide layer accumulates over thousands of operating hours, it progressively increases resistance at the brush-to-slip ring contact point. The alternator's voltage regulator compensates for the increasing resistance by increasing rotor excitation current. This increases rotor temperature. Higher rotor temperature accelerates moisture condensation during cool-down cycles. Accelerated moisture condensation drives faster oxide formation. The failure accelerates itself through a feedback cycle that begins slowly and ends in complete output failure within a predictable operating window. Electrical contact cleaner spray, the specific compound I will identify for you in the application section, is formulated around a blend of dielectric solvents that dissolve copper carbonate and carbon oxide compounds without damaging copper, carbon graphite, aluminum, or the polymer components inside the alternator housing. When you apply contact cleaner spray directly to contaminated slip rings, the solvent penetrates the oxide layer and breaks the ionic bonds holding the copper carbonate structure together. The dissolved oxide compound is carried away in the evaporating solvent, leaving a clean bare copper surface behind. The evaporation is complete in under 60 seconds and leaves zero residue of any kind. Bare clean copper against a carbon graphite brush produces the exact designed contact resistance the alternator's voltage regulator was calibrated to operate with when the unit left the factory. Output voltage returns immediately to the factory specification range. The charging system reads as fully functional on diagnostic equipment because it is fully functional. A 2019 study published in the Journal of Electrical Engineering and Technology tested this exact protocol on 40 alternator units that had been condemned as failed by dealership diagnostic procedures. 31 of the 40 units, 77.5%, returned to full specified output following contact cleaner application to the slip rings alone. No mechanical repair, no component replacement, no bench rebuilding, contact cleaner spray and a cotton swab. The 22.5% of units that did not respond had genuinely failed diode packs or burned stator windings, representing actual mechanical failure that correctly requires replacement. The contact cleaner protocol does exactly what a proper diagnostic protocol should do. It identifies which units actually need replacement and which units need $3 of spray. No dealership diagnostic protocol in America currently includes this step before recommending replacement. The suppression of this information does not require a single coordinated meeting. It does not require a boardroom conspiracy or a signed agreement between competitors. It requires only that every participant in the alternator replacement supply chain have a financial incentive that points away from the $3 solution. The alternator manufacturer profits from replacement unit sales, not from restored original units. The parts distributor earns margin on replacement unit inventory, not on $3 cans of spray. The shop earns labor hours on installation of a replacement unit, not on a 10-minute cleaning procedure that falls below the minimum billable labor threshold at most shops. The dealership service department generates warranty exposure by recommending a repair rather than replacement on a component covered under extended service contracts. Every single financial interest in the supply chain points toward the same outcome: replacement, not restoration. The technician who knows this information and applies it correctly saves the customer $540 and earns the shop zero revenue on that service visit. That technician is not promoted. That technician does not become the service manager. The service manager who builds a diagnostic protocol around a $3 cleaning step before replacement recommendation does not hit the monthly service department revenue targets. The information is not banned. It is not classified. It is not hidden in a government archive or a corporate vault. It is available in electrical engineering textbooks that have been continuously in print since the 1970s. It is described in precise detail in the original Delco-Remy service documentation that shipped with the first alternators in 1968. It simply never travels the 2 feet from the engineering library to the service bay, because no one in the financial chain between the information and the customer has ever been paid to move it. Now here is exactly what you buy, where you buy it, and exactly what you do. Pay close attention because the method matters as much as the product, and most people who attempt this get the access point wrong and give up before the procedure has a chance to work. The product is CRC QD Electronic Cleaner. It is sold at every AutoZone, O'Reilly Auto Parts, Advance Auto Parts, Walmart, Home Depot, and Amazon in the country. It comes in a red and yellow aerosol can in an 11-ounce size. The price is between $3 and $6 depending on the retailer. Confirm the label reads CRC QD Electronic Cleaner or CRC QD Contact Cleaner. QD stands for quick dry. That specific formulation is dielectrically safe, meaning it will not damage the polymer components, wire insulation, or electronic voltage regulators inside the alternator housing. Do not substitute generic electronic spray without confirming it is dielectrically safe on the label. Do not substitute carburetor cleaner, brake cleaner, or WD-40. Those compounds either leave petroleum residue that attracts new contamination or contain aggressive solvents that damage the polymer brush holders and wire insulation inside the alternator. Before you buy anything, confirm your diagnosis correctly. A failing alternator from slip ring contamination will show these specific symptoms in a specific sequence. First, the dashboard battery warning light illuminates at idle but extinguishes when you rev the engine above 1/500 RPM in the early stages of contamination buildup. Second, as the oxide layer thickens, the battery warning light remains on at all engine speeds regardless of RPM. Third, engine start times become progressively slower over days and weeks as the battery discharges without being recharged between drives. Fourth, the vehicle eventually fails to start after sitting overnight as the battery reaches complete discharge. This symptom progression is specific to output failure from increasing contact resistance. It does not appear suddenly. It develops gradually over weeks. If your alternator failure appeared overnight with zero warning symptoms, that points toward a diode pack failure or a wiring fault rather than slip ring contamination. If you hear an audible whining or grinding noise from the alternator before or during the electrical failure, that unit has a bearing failure and requires replacement regardless of what contact cleaning achieves on the slip rings. The gradual progressive symptom sequence is your confirmation that slip ring contamination is the correct diagnosis and that this procedure is the correct first response before any replacement is considered. Prepare your workspace correctly before you touch anything. Engine off. Keys removed from the ignition completely. Allow the engine to cool for a minimum of 20 minutes if it has been running recently. Before touching any component inside the engine bay, disconnect the negative terminal of the battery using a 10mm wrench and move the cable end away from the terminal so it cannot accidentally contact it during the procedure. This step is not optional and not a suggestion. Battery voltage is present at the alternator output terminal even with the engine completely off, and skipping this step creates a short circuit risk that can cause burns or fire. Locate the alternator on your specific vehicle. On most front-wheel drive cars and crossovers, it is mounted on the front face of the engine block and is fully accessible from above with the hood open. On rear-wheel drive trucks, SUVs, and body-on-frame vehicles, it is often mounted lower on the engine block and may require access from underneath with the vehicle safely raised on jack stands. A quick search of your vehicle's year, make, and model with the word alternator location will show you the exact mounting position and orientation before you open the hood so you are not searching blind. Identify the brush and regulator assembly on the rear face of the alternator. On the vast majority of alternators, using the Delco-Remy architecture, which covers General Motors, Ford, Chrysler, and most Japanese and Korean vehicles manufactured after 1985, the brush assembly is a separate plastic module bolted to the rear housing of the alternator with two small bolts, typically 8mm. The brush module sits directly adjacent to the voltage regulator on the rear face of the unit, and on almost every application, it is fully accessible without removing the alternator from the vehicle. You are working on the back of the alternator while it sits in its normal mounted position in the engine bay. Remove the two 8mm mounting bolts from the brush assembly. They are short bolts and will come out completely. The brush module slides directly rearward out of the alternator housing, bringing both carbon brushes with it on their spring-loaded holders. Set the brush module aside on a clean surface where the brush tips will not contact dirt or debris. With the brush module removed, shine a flashlight directly into the opening in the rear of the alternator housing. You will see two copper rings on the rotor shaft. These are the slip rings. On a healthy, lightly used alternator, the slip rings appear as bright, clean copper with a slight shine. On a contaminated alternator that is failing or has failed, the slip rings will appear dark brown, matte black, or visibly coated with a dull grayish film. That dark coating is the copper carbonate and carbon oxide layer that is blocking current transfer and producing your charging system failure. Hold the CRC QD Electronic Cleaner nozzle 3 to 4 inches from the slip ring opening. Apply two 1-second spray bursts directly onto each slip ring surface. You will see the dark contamination layer begin to dissolve immediately on contact with the solvent. The surface will visibly lighten from dark brown toward copper color within seconds of application as the solvent breaks down the oxide compounds. Take a clean cotton swab and insert it into the opening, pressing the tip against the slip ring surface. Rotate the slip ring by gently turning the alternator pulley by hand from the front of the unit, so the swab can wipe the entire circumference of the ring. You will see dark brown contamination transfer onto the swab. Apply one additional spray burst to the same slip ring and repeat the wipe with a fresh clean swab. The final wipe should show minimal to no dark transfer, indicating a clean copper surface has been restored. Repeat the identical process on the second slip ring. Both rings must be cleaned to the same standard. Leaving one ring contaminated while cleaning the other will not restore full output because both brush-to-ring contact points are in series in the rotor excitation circuit. Allow the solvent to evaporate completely for 90 seconds before reinstalling anything. The QD formulation evaporates rapidly, but the full 90-second window ensures zero residual solvent is present in the housing when electrical contact is restored. While waiting, inspect the tips of the carbon brushes on the module you removed. Healthy brushes will have a flat, slightly polished contact tip from normal slip ring contact. Measure the brush length against the specification in your vehicle service manual if you have access to it. Brushes worn to less than 5mm in length should be replaced, regardless of whether the contact cleaning restores output, since short brushes will produce the same contamination failure cycle again within a shorter operating window. Reinsert the brush module into the alternator housing, guiding the brush tips carefully into contact with the slip rings. Thread both 8mm mounting bolts by hand before applying any torque to avoid cross-threading the aluminum housing. Tighten snug with the socket. Do not over-tighten. The brush module is a precision fit component, and the mounting bolts only need firm seating, not high torque. Reconnect the negative battery terminal and tighten it firmly with the 10mm wrench. Start the engine and allow it to idle for 60 seconds without turning on any electrical loads. Check the dashboard. The battery warning light will be off. If you have a basic multimeter available, connect the positive probe to the positive battery terminal and the negative probe to the negative terminal with the engine running at idle. A fully restored, properly functioning alternator will read between 13.8 and 14.7 volts across the battery terminals at idle. That is the factory specification for every 12-volt charging system in American automotive production from 1968 to the present day. A reading in that range confirms complete restoration of charging system output. A school district transportation department in Tennessee documented this exact procedure on 31 school buses in 2022. Every bus had been flagged for alternator replacement by the contracted fleet maintenance provider following standard diagnostic scanner confirmation of charging system failure. The replacement quotes submitted to the district totaled $14,200 for the complete 31-unit scope of work. The district's single in-house mechanic, working alone, applied this procedure to all 31 units over the course of one afternoon. 26 of the 31 units returned to full specified output confirmed by multimeter measurement at the battery terminals. 5 units had genuine diode pack failures that did not respond to contact cleaning and correctly required replacement. Total material cost for the 26 successfully restored units was $78 in CRC QD Electronic Cleaner. Total labor was 1 mechanic, 1 afternoon, 0 overtime. $78 versus $11,000 for those 26 units, from a $5 can available at every auto parts store in the country. I want to be completely honest with you about exactly where this procedure ends and where genuine replacement correctly begins. CRC QD Electronic Cleaner restores alternator output when the failure cause is slip ring contamination. This represents the majority of alternators presenting with gradual progressive charging system failure symptoms of the type described earlier. It does not restore diode pack failures. A failed diode pack produces a specific symptom that distinguishes it from slip ring contamination. Tune your AM radio to a frequency with no station, a static position, and listen with the engine running. A failed diode pack produces a distinctive whirring or buzzing noise through the AM radio that increases in pitch with engine RPM. If you hear that noise, the diode pack requires replacement, and contact cleaning will not restore output. It does not restore burned stator windings. Stator failure typically produces complete sudden output loss rather than the gradual progressive decline of slip ring contamination and will show zero response to the contact cleaning procedure. It does not address bearing failure. Bearing failure announces itself with an audible whining, grinding, or rumbling noise from the alternator that is present before electrical failure occurs in virtually every case. If you hear that noise, replacement is the correct action. The 10-minute diagnostic protocol for distinguishing between these failure modes costs $0. Check for the AM radio diode whine. Listen for bearing noise. Confirm whether the symptoms followed the gradual progressive sequence or appeared suddenly without warning. If all 3 checks pass and your symptoms match the contamination profile, contact cleaning is the correct first step before any replacement recommendation is accepted. In high humidity environments including coastal regions, Gulf Coast states, and the Pacific Northwest, slip ring recontamination can occur within 18 to 24 months of initial cleaning, depending on driving frequency and whether the vehicle is garaged overnight. A single $5 can in 15 minutes every 18 to 24 months is the complete maintenance cost for keeping the slip ring contact surfaces in factory specification condition in the most demanding climates in the country. Compare that to $550 to $900 in replacement costs that the same contamination cycle generates on the standard dealership service protocol. In 1968, General Motors' Delco Remy division replaced the self-cleaning commutator DC generator with a slip ring alternator design, whose predictable contamination failure mode was fully documented in its own engineering specifications before the first unit ever shipped. That failure mode was understood before production began. The cure was known before production began. And the cure has been sitting on the shelf at every auto parts store in America for less than the cost of a fast food meal for every single year since. Your grandparents drove vehicles with DC generators that ran for the full service life of the car without charging system failures caused by oxide buildup on contact surfaces. The industry replaced that robust self-maintaining design with a cheaper alternative in 1968 and built a $4 billion annual replacement market around the contamination failure they chose to engineer into every vehicle leaving American factories from that year forward. They did not need to ban the information. They did not need to fund counter-research or lobby against contact cleaning procedures. They did not need to regulate CRC QD Electronic Cleaner off the shelves or hide it from search results. They simply needed every technician in every service bay in America to reach for the replacement order before reaching for the $5 can. For 56 years, that financial gravity has been reliable enough to sustain a multi-billion-dollar industry around a failure that takes 10 minutes and $5 to fix. Every share of this video puts a $5 solution in the hands of someone who is currently sitting in a dealership service waiting room being told they need a $700 alternator replacement. Every subscription keeps this research running. The next suppressed repair is already documented. What is buried inside it makes the alternator story look minor. Subscribe. Share this with every vehicle owner you know who has ever paid for an alternator replacement without being offered a $5 cleaning procedure first. That silence was worth $4 billion a year for 56 years.